Hello, this is Garrett Torgerson, and this is my presentation on seismic activity and how it is measured. First off, an introduction. In this report, I will be going over how earthquakes are measured, how seismic activity is measured, and the technology that has been developed and is associated with how scientists use it to make assessments on earthquakes and help us as civilians better prepare. First of all, we'll go over plate tectonics. The German meteorologist Alfred Wegener is credited with establishing fundamental principles on the theory of plate tectonics. Seismic activity consists of earthquakes and the ways in how they travel over large distances, how that corresponds with plate tectonics. As we know, at the boundaries, fault lines, slip, strike, subduction, and spreading plates are all examples of plate boundaries, and then the plates North American, Juan de Fuca, and the Eurasian plate, just to name a few. Seismic waves are what travel from the epicenters of earthquakes and ripple out from it. Body waves move through the interior, and sound waves move through on the surface. What we are looking at here is how we can measure these waves and how we do so, and the technology used to do so. One way to measure the intensity of earthquakes is the Richter scale. This was developed by Charles Richter in 1935. And as we can see in our picture down here, we can see frequency and magnitude. We can see that ones, twos, and threes occur at much higher rates than seven, eights, or even nines, which are the highest possible earthquakes. So the first seismograph was actually, or seismic measuring tool was developed in 1932 AD in China. How it works is a weight is placed on bedrock and then a plate on the bottom. When the earth starts to move, the weight or like the weight on top will kind of pencil in on the weight on the bottom, and that will correspond with the shaking intensity. The first shock wave that you'll see on the Richter scale or on the seismograph is the initial P wave that comes through. And the second few shocks, or however many shocks there are within that earthquake, are the S waves. Why is this important? Primarily, earthquakes are the reason used for seismic instruments, but also volcanoes and other magnetic reactions can be used, is also considered seismic activity. As we know, earthquakes come with large amounts of damage to life, the environment, and financial problems as well. For example, the most prominent example is the 94 Northridge earthquake in Los Angeles, which caused approximately 13 to 50 billion dollars in damage. Now, something that we ask a lot is, can earthquakes be predicted? According to the USGS, no scientist or them or any other institution that studies earthquakes has predicted one. The problem is there are three factors that cannot be accurately predicted: the place, time, and magnitude of where these exact earthquakes will be recorded. Instead, they make predictions over some place, over an area of time, and of some magnitude, and with some time over some area. So, like in California, maybe there's a chance of one happening, like a two happening, and that will happen within the next month, probably today, because those happen all the time. There are early warning systems in which alert people, such as California, before the shaking has begun. However, they're not perfect and they are still in training phases. How that works is the first P wave coming through triggers the alert, warning people seconds before the shaking may begin. The future of seismic technology. Seismic imaging is very useful for understanding where and when these earthquakes occur. Also, 3D and 4D modeling helps scientists understand how the ground and crust move when earthquakes occur. Also, AI may also have a future role in helping model and forecast damage for potential earthquakes. In closing, we know the importance of seismic technology and how we use it to ensure we know more about earthquakes and how these were formed and how to measure them and to better prepare for these events. It's very important that we have these tools because without them, we would be unable to, one, see how strong these earthquakes are from past, like, for example, Northridge. We know how big that was, where it happened, and how we can better build houses and freeway overpasses so they don't collapse again um, when there is another one. In closing, that's all. Here are my sources, and thank you for watching my presentation.